This presentation provides a technical overview of VMware vSAN up to and including vSAN 8 Update 1. The ways in which organizations provide services to support their customers and business processes are changing rapidly. Not only are applications changing, but so are the options in how and where to best provide those services. Should it be on-premises, in the cloud, or both? The industry is demonstrating that the combination of the two serves the most use cases. But how does one create a combination of the two using a common set of tools? This hybrid cloud can be achieved with VMware. Let's see how. Hybrid cloud means interoperability, agility, and efficiency. We believe there are distinct steps in this journey to building a true hybrid cloud. The first step has been achieved by most, as they've already experienced the benefit of virtualizing the majority of their workloads. The use of public clouds may also be a key part of your organizational needs. Workloads in public clouds often become another silo to manage and typically is not integrated with any on-premises management tools or methods. Data centers are complex, and the cloud adds to this complexity. The next step is to modernize your infrastructure through hyperconvergence with vSAN. Then add networking and advanced management capabilities with NSX and vRealize. Finally, extend your SDDC to public cloud and the edge to adopt a true hybrid cloud architecture. This approach abstracts operational differences away from where the workloads will be running and provides a common control and management plane to give administrators the agility in delivering services to their businesses. A hyperconverged architecture can remove dependencies from hardware feature sets. By abstracting these features away from the underlying hardware, you can address and apply the right settings in the right way for each workload running in a data center. As organizations are looking for interoperability with other public or private cloud environments, being able to apply these settings in a granular way using software is quickly turning into a requirement. This full-stack HCI can be achieved through VMware Cloud Foundation, or VCF, when powered by vSAN. So why is hyperconverged through VCF better than traditional approaches? Simple. The end-to-end solution that a vSAN powered by VCF environment provides improves on the three pillars of data center management: deployment, operation, and optimization. Data centers are not static. As demands of the applications and its users evolve, so should the environment that powers them. Historically, this has been difficult. However, this new approach transforms the challenges of legacy architectures so that the deployment is fast and tailored to an organization. Ongoing changes are the norms for data centers. With VCF, operations can be performed in an outcome-oriented manner through the use of policies. VMware's approach follows a maxim often used in the world of fast-paced software development: design as if you know it's going to change. First, let's quickly review what VMware offers. Today, VMware's platform offers the levels of flexibility needed for today's rapidly changing IT requirements. It's built off of a foundation of VMware vSphere paired with vSAN. This provides the basis for a fully software-defined storage and virtualization platform that removes dependencies from legacy solutions using physical hardware. Next is VMware Cloud Foundation, the integrated solution that provides the full stack of tools for an automated private cloud. And finally, there's VMware Solutions for the public cloud. VMware has partnered with industry-leading cloud providers that offer services based on VMware Cloud Foundation. This offers customers the ability to build a hybrid cloud consisting of public and private assets, using a common substrate of management and tools for consistent infrastructure operations. Public cloud partners include VMware Cloud on AWS, Azure VMware Solutions, Google Cloud for VMware Solutions, IBM VMware Solutions, and VMware Cloud Provider partners. In on-premises environments where a customer will be utilizing purchased hardware and software, the way that vSAN is delivered to a customer is dependent on whatever suits their needs best. This is why the power of choice is so important. Some want to simplify purchasing, deployment, and management with single SKUs, and this is where VxRail comes into play. Others may have a preference of server vendor or would like to maintain that consistency as they adopt vSAN. This is where vSAN Ready nodes can be a great option. This consumption model offers a great set of choices that fit the needs of each organization in the best way possible. VMware vSphere Plus and vSAN Plus are paving the way for customers to get the best of both worlds moving forward. a unified and consistent VMware cloud experience for all their workloads, no matter where the workloads run. These Plus offerings bring the benefits of cloud to on-premises workloads, combining industry-leading virtualization technology, an enterprise-ready Kubernetes environment, and high-value cloud services to transform existing on-premises deployments into a SaaS-enabled infrastructure that can be purchased through a flexible subscription plan. With vSphere Plus and vSAN Plus, IT admins and developers can easily build, run, manage, protect, and secure their traditional and next-gen applications. Let's take a look at how and why VMware vSAN is the common substrate for a hybrid cloud environment. vSAN provides shared storage by aggregating locally attached disks in a vSphere cluster to create a storage solution that can be provisioned and managed from vCenter. vSAN is built inside of the hypervisor. It integrates with the entire VMware stack, including features like vMotion, HA, DRS, and more. VM storage provisioning and day-to-day management of storage SLAs can be all controlled through the VM level policies that can be set and modified on the fly. vSAN delivers enterprise-class features, scale, and performance, making it the ideal storage platform for VMs. The tremendous efficiency of vSAN means that it can run more VMs per host than any other HCI systems not integrated into the hypervisor. And not only that, but do so with much more consistent levels of performance and tighter integration. This ability to scale up and out, often not possible in the same way when using storage arrays, means that users can strategically design their vSAN-powered clusters to accommodate growth that best reflects the needs of their organization. VMware vSAN uses a data placement approach that is most analogous to an object store. VMs that live on vSAN storage are comprised of a number of storage objects, which can be thought of as a boundary of data. This data is placed across hosts in the cluster to ensure the resilience of the data. What makes vSAN so powerful is that the administrator simply applies a storage policy to one or many VMs that define the outcome or desired levels of resilience, and vSAN takes care of the rest. In the example shown here, we see a VM with an associated storage policy of a level of failures to tolerate equaling 1, using RAID 1 data mirroring technique. This creates 2 copies of data and a tiny piece of metadata on a third host, known as a witness component. The witness simply helps vSAN determine availability during failure conditions. With this object-based approach to storage, vSAN determines the placement of data based on the assigned storage policy. Whether the cluster has 3 hosts or 30 hosts, the policy defines what the desired result will be, and will place and manage the data to ensure the adherence to that policy. vSAN offers a number of data services. These are features or capabilities that can be enabled or disabled on a per-cluster basis. Since vSAN provides storage as a resource of the cluster, this can make it easy to tailor cluster configurations to meet the precise requirements of your organization. When these data services are enabled or disabled, vSAN takes care of the entire process required to achieve the new setting. This makes prescriptive configuration settings quite easy. The vSAN Express Storage architecture provides a new way for vSAN to process and store data efficiently. A new fast and efficient data path paired with an efficient and resilient data structure give our users the ability to store and access data fast and efficiently. The Express Storage architecture also introduces new capabilities such as lightning-fast snapshot engine and new levels of storage efficiency. Finally, the vSAN Express Storage architecture makes administering an environment simpler by improving how devices contribute as a storage resource to the cluster. While the ESA offers revolutionary improvements, this optional architecture is built right into the same software you already know. How does the vSAN Express Storage architecture compare to the classic storage architecture of vSAN? At a high level, the original storage architecture of vSAN was a 2-tier architecture designed to accommodate a wide-ranging set of older storage devices, while the vSAN Express Storage architecture in vSAN 8 is a single-tier architecture optimized for high-performance NVMe-based TLC flash devices for both on-premise environments and for the public cloud hyperscalers. With vSAN 8, VMware gives you the opportunity to select which architecture best suits your existing hardware, while allowing you to deploy new clusters with unprecedented levels of performance. While the vSAN Express Storage architecture is the future of vSAN, vSAN customers should take great comfort that the original storage architecture of vSAN can be used side by side with the ESA and will be supported for many years to come. The power of the vSAN ESA can be fully realized when sizing a vSAN cluster to deliver services for a given number of VMs. Compared to the vSAN original storage architecture, the vSAN ESA allows customers to run more workloads on fewer hosts, which can dramatically reduce the total cost of ownership. Now let's take a look at how vSAN simplifies the management experience of running on-premises, in the cloud, or running a hybrid cloud. Doesn't it make sense to control storage resources on a per VM basis in the hypervisor, just as you do for CPU and memory? Traditional storage solutions couldn't offer this level of control, but vSAN does. Levels of protection and performance are no longer reliant upon the capabilities of an external storage system, but are now controlled and managed by the hypervisor. A user defines the outcome desired and applies it to a VM, VMDK, first-class disk for container persistent volumes, and even file shares powered by vSAN file services. All of this managed easily inside a vCenter. Storage Policy-Based Management, or SPBM, is extremely easy to implement. Using storage policies are as simple as defining the requirements for your VMs, creating a policy that represents those requirements, and then applying that policy to one or more of your VMs. The VM will adopt the new performance and protection settings without any downtime. One can change the characteristics of an existing policy, and the VMs will adopt the most recent settings of the policy non-disruptively. These policies can be applied to VMDKs, VMs, first-class disks for containers, and the file shares served up by vSAN file services. Storage policy-based management is about ease and agility. Traditional architectural models relied heavily on the capabilities of an independent storage system in order to meet protection and performance requirements of workloads. Unfortunately, the traditional model was overly restrictive in part because the standalone hardware-based solutions were not VM aware and were limited in their ability to apply unique settings to various workloads. Storage Policy-Based Management, or SPBM, lets you define requirements for VMs or collections of VMs that can be used with vSAN, as well as storage arrays using vVols. Therefore, a common approach to managing and protecting data can be employed regardless of the backing storage. In addition to traditional vSAN clusters, the power of vSAN also extends to its capabilities in supporting different types of topologies. vSAN can also easily provide site-level protection as well as secondary levels of resilience when deployed as a stretch cluster. This helps deliver effective, affordable protection against entire site outages, as well as host outages within a site. This level of protection is extraordinary and what many of our customers have asked for. Lower TCO is the result of no need to purchase additional hardware or software while addressing protection requirements with software you already know. The flexibility of vSAN's topology also extends to small remote or edge sites. Easily deploy a highly cost-effective 2-node cluster to store data resiliently while also managing it centrally. This makes for a fast, affordable, and flexible management and delivery of services in environments that require this type of topology. Additionally, vSAN Robo Edition licensing has no host limit restriction. There is only a restriction of the number of VMs that may be run in the site. A maximum of 25 VMs can be run in a single site or across sites. Any multiple of 25 requires an additional 25 VM pack license. It's also worth noting there is no upgrade path from vSAN Robo licenses to regular CPU or desktop vSAN licenses. Fault domains are a boundary of failure. vSAN extends this concept of fault domains so that environments can protect against failures, such as a rack failure. It gives an administrator the ability to, 1, determine what the logical boundary of failure should be, for example, a server or a rack, and 2, it defines a logical container that represents the boundary in the cluster. The most common way fault domains are employed are by creating fault domains that represent a rack in a data center. The vSAN data would be distributed across multiple fault domains so that in the event of a total rack failure, no system would be compromised. HCI Mesh is VMware's solution that decouples or disaggregates the storage resources from compute resources that is typically found in an HCI environment. It allows a vSAN cluster or a traditional vSphere cluster to connect to another vSAN cluster's data store. With HCI Mesh, you can easily augment the storage capacity needs of an existing vSAN cluster by mounting another vSAN cluster's data store, or provide the storage needs of a vSphere cluster, reducing or eliminating the need of a storage array. Flexibility and efficiency are two of vSAN's strengths. This flexibility and efficiency extends to the different types of workloads and applications that it can power. Let's take a look at a few examples. vSAN supports all different types of workloads and topologies. Run business-critical applications alongside other applications, or carve out clusters focused on specific application requirements. Whether they be VDI workloads, business-critical workloads, or common IT service workloads, not only can you easily meet the needs of the application, but the flexibility of the architecture allows you to deliver these services in many different ways. House them in a central data center, or perhaps a stretch cluster that spans across two physical sites. Maybe an organization has several branch offices, or perhaps they want the flexibility to expand resources by using the cloud. vSAN can meet all these demands and more, all by using a single management plane, vCenter. vSAN provides a rich set of cloud-native storage capabilities that make it easy for administrators not familiar with cloud-native application development to support an infrastructure used by developers. Containers powered by vSphere and vSAN can easily consume persistent storage in two distinct ways. Containers can mount block-based volumes presented directly from vSAN. These first-class disks can be used by a single pod and can be managed directly in the vCenter UI. Containers can also mount NFS file shares served up by vSAN file services. These volumes can be mounted from several pods and also managed directly inside the vCenter UI. What is most important and potentially the most valuable aspect of vSAN's cloud-native storage capability is the connection that it provides in the control and management of the volume or disk. When developers spin up additional Kubernetes pods, they associate a storage class to define the type of storage it should use. vSAN automatically maps this to an associated storage policy, and this storage policy can then define the level of physical resilience and other characteristics. The developer does not need to know anything about the underlying infrastructure, and the vSphere administrator does not need to delegate the storage for the developer. Native file services for vSAN helps ease the burden of management when vSAN environments require file-level services. Instead of using a legacy physical storage array or deploying VMs to provide file services, an administrator can simply enable this cluster-level service on a vSAN cluster. VMware took a careful approach in how best to provide file services that can easily scale and support a broad variety of conditions. The file services provided in vSAN is an exciting step in that direction. vSAN File Services supports NFS and SMB that addresses most of the common use cases for customers. File Services also now includes support for Secure Authentication Mode, Kerberos for NFS, and Active Directory for SMB. Since File Services is integrated directly into the hypervisor, the administrator enjoys all the benefits as a result: efficiency, integration, compatibility, and monitoring. Flexibility, efficiency, and performance would easily be lost if a solution were not easy to operate. vSAN offers a comprehensive management tool to help you deploy, operate, and optimize environments. Ensuring a flexible deployment model for a vSAN-powered environment means that all types of deployment conditions must be accommodated for. vSAN provides an end-to-end guided installation and configuration experience for the initial and ongoing configuration of vSAN clusters. Easily build a cluster off a single host and extend it through the built-in wizards. Lifecycle management is more powerful than ever before with VMware's Lifecycle Manager. VLCM is a powerful new approach to creating simplified and consistent server lifecycle management at scale. It uses an outcome-oriented, declarative model that makes lifecycle management easy. The desired state, or declarative model, is based around the idea of a user defining the outcome, and the solution monitoring the state of what it's managing, and taking action to achieve this desired state at any time it doesn't match. The declarative model is similar to what's found in Kubernetes configuration tools like Ansible or Puppet, and even storage policy-based management. One of the key differences between VUM and VLCM is how it achieves a result. In this case, the differences in how is important, as it allows VLCM to provide a level of ecosystem support, extensibility, and predictability that couldn't be achieved using BUM. VLCM is focused on server stack lifecycle management at the cluster level, as opposed to VUM, which provided an upgrade patch mechanism for individual hosts. VLCM allows a user to prescribe a set of rules or outcomes to a cluster, and has the mechanics in place to achieve compliance with that set of rules. This is analogous to what SPBM does for storage, but in this case, VLCM produces the outcome-oriented result for server stack management. Administrators responsible for the health and well-being of an environment have a lot to think about in vSAN 8 Update 1, as VMware has developed an all-new cluster health status and troubleshooting dashboard. It helps answer the basic questions of, is my cluster and the workloads it serves in a healthy state? And if not, how severe is the condition? And should the issue be resolved? It provides this information that traditional health alerts alone cannot. For each vSAN cluster, the Skyline Health for vSAN will provide a quick at-a-glance score of the condition of a cluster, so an administrator can easily determine if all is good, and if not, how impactful any identified issues are. The new mechanism uses a sophisticated method of weighing triggered health checks and aligns them with common pillars of responsibility. It then provides the most important, impactful triggered health findings in order of priority so that an administrator can resolve issues quickly and easily. vSAN Support Insight enables a better support experience for our customers. It helps provide VMware Global Support Services with data about a customer's vSAN and vSphere environment. This data is anonymized and then uploaded to VMware's Analytics Cloud, where it is processed and converted to useful information such as configuration specifics, performance, and health status. GSS can get to the troubleshooting effort faster when less time is spent on gathering this data. What does this mean for the vSAN customer? Faster time to resolution, and a direct way to help VMware improve its product experience. Wrapping up, we've seen that vSAN is a hyper-converged platform that is built for the needs of today and tomorrow. No more proprietary storage arrays means that one can provide a compute and storage platform all through vSphere and vCenter Server. Whether the organization chooses to keep workloads on-premises, run in the cloud, or some mixture of both, vSAN can meet all of these needs. And now, using vSAN 8 with the Express Storage architecture, you can do more with what you already have, using software you already know.